All right, so for this problem, we are going to see what would happen if there is unlimited growth. And we're going to first try to change how our years correspond. So instead of saying 2000, we're going to have 2000 be our t is equal to 0, which would mean that 2050 is going to be t is equal to 50. So when there's unlimited growth, our function is going to take the form y of t equals uh, the initial value times e to the rt. And we will need to figure out what this value is. Our initial value here, p of 0, that is going to be this 35.5. So we can plug in these values over here into our equation and then solve. So we would have 60.6 equals our initial value, which is 35.5 e, and then we're going to need to figure out what r is, times 50. Okay, so we're going to then need to solve this. So the first thing we're going to need to do is to divide both sides by 35.5. So 60.6 divided by 35.5 would give us this number here. So we'll have 1.707 is equal to e to 50 times r. Okay, we can then take the natural log of both sides. And when I do that, I'm going to go ahead and put natural log of this value here. And that's going to give me 0.5347. So 0.534, and then instead of 7, I'm going to put 8 for rounding purposes, will give me 50 times r. And then I can divide both sides by 50 to figure out what the r value is. And so with that, I'm going to get that r is about 0.01. So rewriting our formula now with this for my r value and this other part for my initial value, I would have y of t is equal to the initial value, which is 35.5, e to the 0.01 t.